Last year in the American Journal of Physics, there was an interesting essay by a philosopher of science named Lee McIntyre. He's at Boston University. He got interested in a certain kind of science denial, namely flat Earth theory, the notion the Earth is flat. And in the American Journal of Physics, he was asking for physicists to help him rebut the arguments of the flat Earth movement. And this movement goes back, as we'll see later, to the mid-1800s in Great Britain, and has had a certain renaissance in the last few years in several places, notably Britain, United States, and Brazil. And I will talk about some of the history later on. It's true that the science denial of the variety that the Earth is flat isn't nearly as dangerous as science denial of vaccination or climate change, but it's not harmless because it supposes that all scientists and all governments are in a grand conspiracy to hide from the people the truth that the Earth is flat. And to the extent that that's dangerous. If you label all governments and all scientists as in cahoots to hide the truth, that's not good. There, of course, have been many attempts by scientists to rebut the flat Earth notion. But when I saw this essay from Lee McIntyre, I got interested, made contact with him, and we started to work together. And also a friend of mine, Derek Roth, got involved too. And as I got into the subject, what I found was that scientists' well-meaning attempts to rebut flat Earth theory were not very effective. They tended to base their arguments on data, information, observations that are not accessible to the ordinary person, and certainly not just by what you see. And for example, one of these things that I found on the web by a scientist started out, since we know that the sun is nearly 100 million miles away, therefore, well, if you walk outside your house on a sunny day and you see the sun, you have no obvious naked eye observation mechanism for determining how far away it is. So the fact that it's 93 million miles away is mostly rote learning on essentially all of our parts. I mean, it's not that trivial to figure out how the ancients got even an approximate distance to the sun, though they did, and how we know that it's 93 million, not some other number. That's not trivial. And a piece of that, the rebuttal issue, is not only that these arguments were not very convincing if you are a flat earther, but also the flat earthers privilege naked eye observation. And this has its positive aspects. The idea is, I believe what I personally can see with my own eyes. And that's actually the beginning of science, right? You see what you see, and then you try to understand it. Unfortunately, it doesn't go far enough, as we'll see, because when they come up with an alternative model of a flat Earth, they have not actually checked whether their model is in agreement with even naked eye observations. And so what I was able to bring to the table was an emphasis on what are the naked eye observation consequences of your model. Now let me show you a picture of their model. It's actually quite amusing in a way. I hope you can all see this, this model. Here's the Earth is supposed to be a flat, non-rotating disk. The center of the map is at the North Pole. By the way, notice that means that distances between places like Australia and South America are very, very far indeed. And you see the orange ball under this, and then there's transparent dome. It rotates around the North Star, which is above the North Pole. So the stars leave trails that will be circles parallel parallel to the horizon. Now, this model doesn't actually show it, but in many of the at least US models of this, there is no Antarctica, obviously. Instead, if you try to get farther than the rim of this flat disk, what you will come to are high ice cliffs policed by the armed soldiers of many countries who will prevent you from trying to go past that point. So there's conspiracy piled on conspiracy. So that's the model we're looking at. And I might have been the first person to take their model seriously in the sense of trying to see what it would actually predict. And we'll see more about that very soon. Well, so that was what I showed you was essentially the US version of the flat Earth. The British version is a little bit different. Both groups, and apparently the two groups are very much rivals and don't agree with each other. Both groups assert not only is the Earth flat, but there is no such thing as gravity. Yes, there's certain kinds of buoyancy things. Some things rise, some things fall. It's in the nature of the denser things to fall. But there is no such thing as gravity, and the proof of that is that no one has ever seen two objects attract each other. Just never ever seen that. Now, this is just plain lack of knowledge. They don't know that 200 years ago, 1798, Cavendish actually saw two objects attracting each other. But they believe this has never happened, and there is no such thing as gravity. And the British model is quite interesting in this respect. In the British model, that their flat Earth is constantly accelerating at 9.8 meters per second forever. And this has been criticized by scientists because you would exceed the speed of light very soon. But no, that's actually not even right, because in the rest frame of momentary rest frame of the Brit standing on this accelerating platform, you're always accelerating at that speed. From us looking from the outside, it will approach the speed of light. It won't reach it or pass it, of course, but it's not a problem with relativity. It's a problem with facts. But the notion that there is no gravity is kind of interesting, and it's motivated in part by the fact too that if these people who believe in this silly spherical Earth, the Australians would be upside down and would be required something of pulling them up, which there doesn't exist, and so on. So that's a big piece of that whole thing. They also assert that all those nice NASA pictures of the Earth as a globe, they're all fake, and we never went to the moon. In fact, the notion that we never went to the moon is actually fairly common. Ruth and I had the experience of a student asking us, did we think that we'd gone to the moon? And our answer was, well, yes, because you can't keep that big a secret so secret out of, there are thousands of people involved in that. But moreover, there was no special science or engineering required to do it. You just had a lot of hard work. So why wouldn't you go there? It's not a big deal. So that's kind of the situation. Now, this notion that naked eye observations are privileged goes back to the notion in part that the world looks flat, right? I mean, yes, there are valleys and mountains, but the world looks flat. And so there are some weaknesses in using that only. And one of the issues is that not only do the flat earthers not actually check to see what their own model would predict naked eye observations would be, but they also don't recognize or acknowledge the notion that we have learned more than just naked eye observations will tell us by inventing things like microscopes and telescopes and all sorts of devices. No human being has ever seen a virus by naked eye observation. And it's pretty hard even to see a bacterium. So that's another weakness. In some ways, they are scientific. They have a model. They say that naked observations matter, and so on. But there are a number of crucial steps in a scientific attitude toward finding out about nature that just are not part of their belief structure. Now, in trying to understand their own model and thereby see whether that works out or not, I was led to create a navigable 3D instance of their model that I could wander around in. And so what I want to do next is actually take you into that world and show you how some things go wrong in that world. So let me share my screen on that. Now here you recognize something that looks a lot like what we saw before. This is their model. Notice that their universe is very small. It's really a tiny universe because this is all there is. It's not like there's some more stuff. There is this disk, and I'm going to go in here, and I'm just past the ice wall, so I'm basically in Antarctica now, south of Argentina. And above me are the trails of the stars, the lights that are embedded in that rotating dome that goes over this. And notice that here we are in Argentina. There at the center of those orbits that you see is Polaris, the North Star, which is about 45 degrees above the horizon in Argentina. Now, this is just slightly problematic. If you're Argentina, you don't see Polaris. In fact, if you're in Ecuador, if you're on the wrong side of the line, you don't see Polaris. So this is already a very, very striking example of how wrong this model is. Also notice that those orbits of the stars, they call them lights. There are no stars. There's just lights that are carried around in there. They're ellipses. But in fact, anywhere you take these pictures, though you have to be north of the equator, those orbits are circles. The only place where there are circles in this model is if you're at the North Pole itself. So that's not quite right. This yellow thing here, that's the sun. And it is positioned a few thousand miles above the Earth in order to have about the right size. It's supposed to be about 30 miles in diameter, and it's 3,000 or 4,000 miles above the surface of this flat disk. And there ends up being a whole bunch of issues with that, because if we let this model run, what you see is the sun, which in their notion is a kind of a spotlight. So it just winked out now. It's over on the dark side of the Earth at the moment. So we're now in nighttime because we're not getting anything from that sun. Here it's coming around again to us, and I'll pause when it reaches us there. So I paused there. This is sunrise. Now, do you see anything odd about this sunrise? Well, the fact that it's like 30 degrees above the horizon seems a little problematic to me. And there's something else interesting that happens. Let me move forward to being near the equator. So this is basically the equator at an equinox. And we'll look up here, and there is the sun. And now I'm going to run through part of the day. Notice how big the sun appears at this moment, about a half a degree, which is what one actually sees in real life. But as it comes closer to us, and let me keep watching here, gets closer and closer, it's getting bigger. Now, no human being has ever seen this effect. And it's a simple naked eye observation. From sunrise to noon to sunset, our sun doesn't do this. It doesn't change size. And a key issue here is that we're in a situation where everything is nearby. And therefore, as you move or you look around or the day progresses, things change. Here's another example. Running along over there on the side, and there's a bunch of constellations. There's the Triangulum constellation, if you like. And notice that as I look around here, it gets closer to me and they get bigger. The size actually changes. In fact, if I go over here near to that edge, it's quite dramatic. So that's something we've never seen. Moreover, these constellations and these stars are always moving parallel to the horizon. The only place you see that in the real world is at the poles. If you're at the North Pole, yes, you will see stars, constellations going around you. Their trails will be parallel to the surface. Derek Roth pointed out that a problem with having the sun as low as just a few thousand miles above the surface and never gets down to actually sink below that surface, which by the way would make it nighttime everywhere because it'd be below the disk. That also means that you couldn't see low-lying clouds illuminating on their bottoms. In fact, it's not uncommon at sunset for low-lying clouds to be illuminated by sunlight that's coming up from the setting sun, because the sun gets all the way down to the horizon and you can illuminate the lower part of those clouds. So there's just one thing after another. So you get these elliptical orbits, which is wrong. And here's a really dramatic thing that occurred to me only very recently. Although, let me just interject this. Time and time and again, it's been clear in the history of science in general and physics in particular, that visualizations make a difference. And I think that it was only with this visualization that I noticed so many, 6 or 7, strikingly different behaviors of the model from what naked eye observations actually shows you. But I needed that visualization in order to see this. I couldn't just, in my head, I couldn't visualize all that stuff. Einstein, I think, did it, right? He could visualize it in his head. But for ordinary mortals, having a visualization can make a huge difference, as I noticed. And then this thing hit me just a couple of days ago that I find particularly amusing. Not only in this world should you be able to see the North Star, even in Argentina, but we here in the Northern Hemisphere, we ought to be able to see the Southern Cross. Well, all the stars should be visible. We know from anybody who's done astronomy in the Southern Hemisphere, there's a whole hemisphere worth of southern stars and constellation, 2 pi steradians of it. And we here in the North have 2 pi steradians of a northern set of stars and constellations. There isn't room in the flat Earth people's dome, this hemispherical dome, there isn't room to squeeze in 4 steradians of constellations and stars. So for so many different reasons, it just doesn't work at all. So why would anybody believe in this? And I repeat that the key issue here is, and the problem is, this is a very small world. Things are near each other, and that has all kinds of consequences for just naked eye observations. To say nothing of a lot of other things that we can do that show our actual situation. So let me switch now to talking about why is there even a flat Earth movement? First, a little bit of a history of how and why we know that the Earth is round. it's sometimes taught even in schools. Our own son commented that he learned in school that it was Christopher Columbus who showed for the first time that the Earth was round. No, no, as we'll see, we've known for over 2,000 years that the Earth was round. What Columbus did was cheat on what everybody knew how big the Earth was, as we'll see in a moment. He tried to argue that it was actually a much smaller radius than it actually is, small enough that the Earth was small enough that he could get from Spain to China without starving to death on the ships that couldn't carry the amount of stuff they'd have to have if the Earth was as big as everyone knew it had to be. I don't know why Isabella was willing to fund this guy, but he was getting close to running out of food at the time when he ran into land, but it wasn't exactly China. Christine Garwood, a British author, wrote a very good book titled Flat Earth, The Story of a Strange Idea. And she comments that it's apparently the case that in Egypt and in Babylonia, their cosmology did indeed have in view a flat Earth. But Aristotle traveled to Egypt and went south in Egypt and noticed that he was seeing constellations that were unfamiliar to him, and he was not seeing constellations that were familiar to him. Now remember, in ancient times, the night was dark. The sky was dark. You could actually see stars and the Milky Way. And so people were much more familiar than most people are now with what you could see in the heavens. So Aristotle saw what he saw, and he concluded correctly, oh, the Earth must not be flat. I bet it's a sphere. And about a century later, a polymath named Eratosthenes, who was the librarian of the great library in Alexandria, he made all kinds of contributions in geometry and science of many kinds, including on measurement that is fairly well known that I'll share with you, which is here. Oh, I should stop here and pause and say, this picture actually appears in the major US Flat Earth site, which is supposed to show, as the stars go around the North Pole, it's supposed to show why the round Earth theory is completely wrong and their Earth is completely right. And actually this picture is one of the many strong proofs that their model is wrong. So Eratosthenes made the following measurement. And some of the details are a little bit vague because not all of his work was we still have, but there were people who commented on it. Anyway, it went something like this. He knew of 2 places in Egypt that were a known distance apart because there was surveying that the Egyptians did. So they knew how far apart they were. They differed in latitude, but not in longitude. They were nearly north-south of each other. And in the northern one, at I guess it was an equinox, the sun shone straight down and a vertical rod left no shadow. In fact, I think it was a well, and people saw the light went straight down into the well. So in the northern place, there was no shadow, and then a certain distance, a known distance below that, he measured the angle of the shadow cast by a second vertical rod, that is locally vertical rod. It is said that it's often said that proved that the Earth was far away and that the sun was far away, and from the angle you can get the radius of the Earth, which he got with a precision of a few percent actually. Now, in fact, if there hadn't been Aristotle's observation, and perhaps, I don't know this, maybe Eratosthenes noticed that the sun didn't change size during the day, this measurement by itself isn't sufficient to tell you whether the Earth is round, with a radius of 4,000 miles, or the Earth is flat with a sun that's 4,000 miles above the Earth. The geometry in the algebra is exactly the same. So this measurement doesn't actually distinguish between these two interpretations of his measurements. I assume that it was Aristotle's testimony that convinced him to pick the far sun model rather than near sun one. I can't prove that, I don't know that. But this is, so this happened, 200 years BC, and what Christine Garwood in her Flat Earth book claims is that from that time forward, at least in the West, there was no question. Everybody agreed that the Earth was a sphere. And the increasing in the voyages of discovery also added a lot of confirmation to that, because as sailors came toward a port that was backed up by mountains, they routinely saw that they saw the tops of mountains long before they saw the whole mountain and the city in front of it. So the Earth was round, and there was no religious issue in this either. The problems that Galileo got into and Copernicus wasn't that the Earth was a sphere. That was widely accepted, including by the Roman Catholic hierarchy. What they objected to was having the Earth not at the center. That was not okay, but there was nothing wrong with the Earth being round. So for over 2,000 years, at least in the West, the Earth was known to be a sphere, even knew how big it was, and so on. So where did talk of a flat Earth come from? Well, she points out that it started in the mid-1800s in England. And why then and why there? It was a time when science was growing in power and capability, and perhaps with interest generated by the Industrial Revolution and the need for coal and iron and other minerals, geology got a huge boost. And Lyell, there were other geologists on the continent at that time, but Lyell is often, the British geologist Lyell is often credited as being the sort of the father of modern geology. And what people were finding was geology was showing that the Earth was much older than had been suspected. And they were also finding in the strata, they were finding fossils of creatures that no one had ever heard of or seen before. So there was a ferment there, and it was perceived by some people as being threatening to religion. It needn't be thought of in that way, but that was a possible reaction. And so here is let me give a citation of something. I'll share screen again to show you one other thing, which is from the very first page of the most important US flat Earth community is this. And on that first page, and I'll read it out loud because it's so compelling. On the first page, there is this statement. The majority of people believe they are descendants of monkeys living on a giant spinning ball of water, hurtling and spiraling through space, all of which was not created, but was formed billions of years ago in some outrageous cosmic explosion that created everything from nothing. If this were true, it would mean we are insignificant pieces of cosmic dust. We aren't special in the least, without a purpose in being here. Our self-worth and outlook on others and the world as a whole is warped. Well, the exact opposite is true. We are special and are not some random result of a billion-year-old explosion. Now, this could not be more clearly seen that there is can be a very strong religious connection between flat Earth theory and at least some forms of religion. And I feel I can put this in a larger context by citing the work of Karen Armstrong. She's a British author of religion and a scholar of religion. She's expert on all the three major monotheisms. She's actually taught in Islamic schools. She's been a nun. She's she's associated with Jewish institutions. She's written a number of very influential books. And one of them is titled The Battle for God, Fundamentalism in Judaism, Christianity, and Islam. So in the case of Judaism, she's talking about Orthodox Judaism. Christianity is typically Protestant fundamentalism, especially U.S., and various forms of fundamentalism in Islam. One of her key points about her history of fundamentalisms is that the fundamentalists conceive of themselves as hearkening back to a wondrous previous age, when in fact they are all very recent. And it's not a coincidence, in my view, that she pegs the beginnings of fundamentalism on the order of around 1800. And she sees their rise as being an expression of an acute discomfort with a threat as perceived by some, especially traditionalists and especially fundamentalists, as science being a threat. They saw science as getting more and more power, more capability, and having a weight of authority that they felt they needed. There was almost a kind of an envy of science and a feeling that we need to have something like that ourselves. And she makes the following very interesting division. She says, there consider two ways of being human and engaging in being human, which she calls mythos, storytelling, which we tell stories to get at things that it's the only way we can communicate them. And a good story can get something across that won't come across in any other really way. And science won't necessarily illuminate it either, given it's about humans. So mythos on the one hand, which she's not putting down, I emphasize, she's seeing mythos as vital to being human. But she says then there's logos, the word, science as an example, rationality, using reason, and both are equally important in being fully human. The problem comes about in the fundamentalisms that have arisen of confounding the two. And so she says, what happened was there were people in, especially the monotheisms, who wanted to establish the sacred books not as mythos, but as logos. And she considers this to have been a disaster for all of us. And she looks for ways to bridge a very, very gulf that she sees between those who see mythos as important but not the same as science, and those who see science as being what it is, even though it may not tell very good stories all the time. So I can't help thinking that the religious aspect to the flat earth theory is very powerful. And I showed you that citation from the first page of the US main flat earth website. I also have viewed a speech at a US Flat Earth conference. They're now having annual conferences, which bring several hundred people to them. And I watched a very long speech by a person there who very often in the speech used phrases from the Christian and Jewish Bible to prove that the earth must be flat. Moreover, every time he cited that evidence, there was great applause from the audience. So the connection seems very, very strong. And this is problematic for us all. The Bible has, and the Quran have really important stories to tell us with a lot of psychological insight and psychiatric insight and political insight even. But they are not science textbooks. They're not a reference book to go and find out the size of the universe. In fact, the Bible in the Old Testament does have probably one of the first measurements of pi, which is 3.0, because there's a description of a fountain that's 2 meters across and 6 meters around. But I don't go there for an accurate value for pi, because that's not the right place to get that sort of information. I can find other kinds of information there. I'd like to strongly acknowledge Lee McIntyre, the philosopher of science, for bringing this issue to my attention. It was wonderful working with him and with Derek Roth as the three of us tried to figure what we could understand about this. McIntyre would like very much in his studies of science denial to use this particular variety of science denial as a sandbox to try out mechanisms for reaching these people. One of the many problems in scientists' attempt to rebut them is that they're often very disrespectful of them. They're all idiots, they're stupid, they're I don't want to have anything to do with these dumb coughs and so on. That's not helpful. and one of the things the three of us tried to come to was, look, let's be as respectful as we can. And one of the possible forms of respect could be to take their model seriously and then see where it leads. And maybe they could be encouraged to rethink their model, tweak it or something, or maybe someone would think differently about it. But it's a problem, it's an issue. And Lee actually went to one of the Flat Earth conferences and got into deep conversation with many people there, and they were fine people and they weren't stupid, but they had got somewhere, they'd gone down the rabbit hole. And there's some evidence by people who study these sorts of things that when you find some conspiracy kind of thing on the web, you go down that rabbit hole, you're very likely to find a neighboring rabbit hole. And there's a tendency to share conspiracy theories, not stop with one. So there's multiple issues here. I'm really delighted that McIntyre is thinking hard about this. And I commend to you not only the book by Christine Garwood, the book by Karen Armstrong, but also a recent book by McIntyre. Last year he published a book on titled The Scientific Attitude. And I'd like to say just a few words about this, which might encourage some of you to read the book. I found it very illuminating. First of all, he tells this reader who didn't know this, that philosophers of science long ago abandoned the notion that there was such a thing as a scientific method. That's interesting to me because it's still taught in school as rote learning that there's this scientific method that you have a hypothesis and then you design an experiment and okay. Well, what McIntyre points out that historically is scientists gain new knowledge by hook and by crook, whatever works. If you get your theory first, that's fine. If you get the experiment first, that's fine. There isn't really a cut and dried thing called a scientific method. What he does identify is what he calls the scientific attitude. And you can guess from the title what that means. It means that there's a certain kind of attitude of a genuine scientist that, for example, all results are to be considered challengeable, temporary, subject to change if we learn more. And there's the notion of peer review. There's a whole set of things that go to an attitude, which he identifies carefully as not something that an individual scientist has, but that a community of scientists have. It's a community attitude. And to give an example of the power of this notion, which apparently was really kind of a new idea with him, to put it this way, was that he was able to attack what's been a long-standing issue in philosophy of science and the history of science. Again, I was clueless about this, that there's something called the demarcation problem, by which was meant in that community of scholars. How do you write down criteria that can, without false positives and false negatives, distinguish between true science and pseudoscience? And one of the key reasons, if you think in terms of scientific attitude instead of scientific method, is that if you see something that says it's trying to be scientific, but they're unwilling for any new information to change anything about their dogma, then that's a really, really clear, establishable criterion that it's pseudoscience. And it may seem odd to you that it's not trivial. Shouldn't it be trivial to distinguish between pseudoscience and science? No, actually, it has not been easy over the decades to try to write down something that clearly, cleanly, without marginal cases that you couldn't really decide very clearly on the criteria that you'd all accepted to write down. One of the other things I felt that I learned from the excursion was something about a kind of thinking that we're seeing with respect to the virus. It's sometimes the highfalutin term is dichotomous thinking. I could say black and white thinking. You've seen that there's been pushback against the health authorities talking about the virus, in part because they would say, well, in the beginning you said we didn't need to wear masks. Now you say we should wear masks. Oh, you said X, and then you said Y, and then you said Z. And I'm through listening to you people, you can't make up your minds. That is, of course, a strength of science, not a weakness. That we are, in fact, congenitally willing to actually challenge what we thought we knew. Yes, we'll put up some resistance, but ultimately we will cave in to better evidence than we could muster. So changing your mind because of new evidence or new rethinking is a strength of science that is possibly not well understood by the public in general. And I'll give you another example that I find awesomely compelling and dangerous, the vaccination issue. And it goes like this. When you vaccinate people, some of them die. They're allergic, whatever. They have allergic reaction. Some people die from being vaccinated. Does that mean that you should abandon vaccination? Well, no, we should say, because the number of deaths, if you don't vaccinate, is vastly larger than that. But to the dichotomous thinker, the advice to vaccinate or not vaccinate or something, it's 100% or it's zero. If it's not perfect, it's worthless. And we see that in the case of vaccination too, as well as in the virus issues. So I feel like I've learned quite a lot from hanging out with Lee McIntyre and reading his book, and I commend it to you. 2019, Lee McIntyre. And there's one other thing to share of the screen, which is, this is where you can see my blog article, which goes into this in some more detail, and it includes a link to the program I showed you and instructions how to use it. And I would welcome in the chat window any comments you can offer. Or questions, or objections.
Oh, can I ask you a question?
Please.
So actually it's more than a cry for help, because what is the path forward? You said that visualization might help, but did it? So did you try this visualization on the flat Earth on somebody who thinks that the Earth is flat? Are there plans for doing this? And in general, I mean, that's the problem how do you talk with these people?
Yes, how do you talk? So this is what Lee himself is trying to study. How do you reach them? Um, what I what I hear Karen Armstrong suggesting is that it's not just them that have to be reached; it's us that also have to be reached. She's Karen Armstrong speaks eloquently about the need for building bridges, and that so my answer to you, Marco, is basing on Lee McIntyre and Karen Armstrong. I would say the challenge is to find ways to approach people who have got suckered into these conspiracies in some respectful way. That's the beginning wisdoms here. Be respectful. In my case, I feel I'm being respectful by honoring their model and taking it seriously and see what it predicts. Um, yes, I think their model doesn't work, and I think I've seen that it doesn't work. But I found when I was first writing my blog article, my own instincts were all on the kind, these people are just pathetic. That's not going to get us where we need to go. And I'll give you another example from Karen Armstrong's book on the battle for God. We right-thinking people see the Scopes trial as a victory for the good guys. Yes, he had to pay the teacher had to pay a fine in Tennessee for teaching about the evolution, but at least Bryant was so humiliated he died in a few months, and what she points out is that before the Scopes trial, there was, and I experienced this some as a kid actually in schools, there was a fair amount of intercommunication between the American fundamentalists and science, because they sometimes saw science as showing the wonders of nature, which were God's creations. In fact, when I was in junior high school, we saw movies put out by the Moody Bible Institute, which had time-lapse photography of flowers opening up, were showing us the wonder of nature and of God. So that was true for a while, but Armstrong identifies that the Scopes trial made those fundamentalist communities feel so dissed and disrespected and humiliated that they retired into a shell and festered there with a little communication in or out. And we've seen how very serious the problems are that has awakened. And Armstrong argues cogently, look, we on the outside of those shells actually have more tools to bring to the problem of how to make the cross communication. It is actually our responsibility to try. And there is one stellar thing that's happened in the last decade or so, and you might not all have heard of this, but there has been some serious, very good, respectful communication between fundamentalist Christians in the US and the need to do something about preserving nature because we need to be custodians of it. It is a Christian belief to be custodians of the earth that they see as created for and with them. And there has been real communication between two camps that's really helpful. At the same time, I have to admit, Lee McIntyre is still puzzling over how to do this, but he's thinking really hard, and he's spending time on it. But I think you can see these are actually important issues. The flat Earth theory by itself is, who cares? It kind of doesn't matter whether you think the Earth is flat or not. It's in some ways, but not if you think that it means that all science lie to you. But the issues are much larger than just that one. The issues of the teaching of evolution, the issues of they're being destroyed by the globe heating up, all those things, they're all folded into this to some extent. Thank you, Duncan. I just read in chat.
Can I ask a quick question?
Please.
Yeah, that's a great talk. I'm very interested in philosophy, so this is a very interesting personal for me as well because of my parents are really intense science denialists, and so it's I just wanted to ask my impression is that there's a sort of consensus that has formed in psychology or is maybe forming, and a lot of philosophers believe this as well, is that there's really more of what might be called a non-cognitivist explanation for science denialism, and in that science denialism is not really predicted as much by lack of knowledge about the science or lack of intelligence, but more predicted by things like value commitments and emotionally loaded reasoning and group identity. um, doesn't this kind of, if, well, first off, I'd like to know what you think of that, if you, as what you think of that idea that that's maybe the bigger explanation, and also doesn't that kind of undermine the idea that this is the sort of thing that you could reason them out of it, like it might be that reasoning, just even trying to reason with these people in any way is not going to work because of the group identity and value commitments uh, are really what's causing them to rationalize away any attempt at reasoning them out of it. Yeah.
Greg, I thank you so much for saying this. This is one of the things I meant to talk about. So thank you
Yeah,
for
and you
bringing
did
it up.
address it, and you did address it, I think, pretty heavily already. But yeah, I just wanted to.
But I can address it more directly. Yes, it's very clear that in the flat Earth community, at least, it's very clear that what counts is the other people. It's a social phenomenon. They find real pleasure in being together, in sharing something that where they know stuff that those stupid scientists don't, in their blindness. Uh, it's a social phenomenon. It's exactly what you say. Interestingly, on the one hand, you will find um, on their websites, there's the one that's 100 ways in which the round Earth theory is all wrong, um, and and there's joy in all this. They're willing to believe that the hundreds of thousands of people involved in going to the moon and other NASA projects have managed to keep a secret, um, and 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 also that no scientist is trustworthy. You shouldn't believe anything they say. And yet they are willing to take the word of the a few leaders in the flat Earth community, um, without actually thinking for themselves, actually going and looking at the world, and seeing whether what the leadership is telling them is true. It's not that I think the leaderships believe in this too, but that you pin your truth on this one random guy, and you nix all them scientists who are just conspiring against you. But it's very clear. There's a very strong tie. I saw a video, YouTube video, that was done rather intelligently, where they brought uh, 3 scientists and 3 flat earthers together to have a kind of a panel discussion with the interviewer throwing a question and giving both sides to talk about it. And sometimes they had they'd put all the people off in the wings and then bring just the scientists back, say, or just the flat earthers. It was very interesting when they brought the flat earthers back to talk just about for themselves. 2 of them had bonded instantly because they both saw the Bible as the authority that proved the earth must be flat. So I kept running into that. So it's social, it's religious, it's the thrill of conspiracy. It's a lot of things of that kind. And thank you, Greg, for bringing it up, because yes, that's absolutely a very powerful driving force. Now there's a note here. Let me just quickly read it for myself. Yes, that's right. You all might want to read this in chat. Um, They will believe non-scientific things in the face of compelling comprehensive evidence. Doesn't matter what arguments one uses, it just makes them angry. I've been categorized as cognitive dissonance disorder. Yours seems optimistic. Well, I'm trying to be optimistic. Following with Dr. Marcus, with Marcus' question, will this have any effect on such social groups, or is there some other reason for such people's dissonance? Um, I don't know what to say. I feel that I don't have the tools to bring to the analysis of the why. Um, my father was a fundamentalist, so I'm somewhat familiar with what that belief structure looks like. He really believed that the fossils had been planted by scientists to trap the unwary. He really said this, and I think the best take on it is Karen Armstrong's book. So you might like to read that. Something else. So from Greg, you posted this link, which takes you to what's the link about, Greg?
Oh, it's one study from Pew about global warming denialism, in which the denialism seems to track, not so much with it, you could predict how uh, interested someone was in science from their, uh, it didn't seem as though knowledge of science was really that strongly associated with how, like, knowledge didn't seem to immunize someone against uh, believing in having an absurd amount of science denialism. It seems as though often, I mean, and this fits with my personal experience as well, that often the young Earth creationists that I grew up arguing with, or anti-vaxxers, knew more about these subjects than I did even, and so it seemed useless to argue with them because they are obsessed with the subject matter, and it didn't seem as though I could come up with it. Yeah, go ahead. Sorry.
Let me ask Ruth Shabbat. I realize we're going to run over just slightly here, but Ruth, could you tell your experience about Grove City?
No, I don't think so.
Okay, well then I'll summarize it. That's a warning. That's a threat. So Ruth had the very good experience of seeing it at Grove City College, north of Pittsburgh. She was on a visiting team, visiting the physics department there. And it's a very Christian school. But they actually teach about the round earth and evolution and so on, so that people have more than one viewpoint. And she saw it being done very well. And ironically, it's easier to do such a thing at a Christian school than at a public school where you're not really supposed to be talking about religion. So I see we've come to the end of our time. I'm happy to stick around and chat with people if you wish to, but it is 4:31. Thank you, Yuri.
Thank you. Thank you very much. And again, like if somebody would like to stay and talk, and you are host, so you decide when
Okay.
you're going.
All right.
I have a question. Have you ever actually shown a flat earther this model or tried to kind of talk to them about their beliefs? And how'd it go?
I unfortunately have had no connection at all. I missed a connection in one sense. There it was intended that Lee McIntyre and Derek Roth and I would go to the 2020 Flat Earth Conference, which was held in Dallas, actually. But at the last minute, Lee wasn't able to do it. I think this was before the virus had hit, but we didn't go to that conference. But Lee still wants the three of us to go to a conference and engage in conversations, hopefully respectful conversations, with the people there. He had a good time at the conference he went to. It was his first experience. He found people pretty open to conversation. He thinks that they would be interested in my computational model. So we're going to try, Kelly, and with Lee, the expert on this, trying to understand. He did find that he made some headway at that conference he went to when he asked the question in this form. He said, "Can you imagine any kind of new evidence that would change your mind at all?" And that kind of stumped the interlocutors, who basically kind of admitted, no. It was inconceivable. There was no way that new knowledge, new observations, new interpretations could change what we now know is the truth. But the person squirmed a little at this. And so Lee thought something like this might be a scheme. I've tried as best I can to get this work I've done known, and it has been cited in a few places now. But how to reach them, I don't actually know. Stay tuned.
Yeah, I think it's great that you're doing this. I do agree with Yaor that it's optimistic, but that's probably a good thing in science, right? If someone wants to leave their group, they should have a place to go. So. Thank
you, Kelly. I'll mention a technical point. That program is written in something called GlowScript v Python. It's housed at glowscript.org, where your Python program gets transpiled to JavaScript and runs in the browser. So you don't have to install any software. Just go to brucesherwood.net and read the article there, A Flat Earth ? Well, if there are no other questions to be raised, thank you all for coming and asking good questions and reminding me of what I'd forgotten to mention. And it was fun. Thanks.